Okay, so we've got one more method to cover, and remember the point of intersection, just to kind of review some of the last few videos. The point of intersection is where the two graphs visually intersect, okay? And if they're the same line, then they will intersect infinitely many times, but you're going to have to generate those values. So if that comes up again, I'll kind of show what I mean by that, if that was a little confusing. But your goal of elimination is to eliminate one variable by matching coefficients. And so what you can do is you can take a whole equation and you can operate it on it with multiplication or division. So if I take a look here at example 1, what you should notice is that none of the coefficients match. So 6 doesn't match with negative 12 in front of the x's, and then negative 5y and 2y do not match. So what I'm going to have to do is I'm going to have to multiply one or both of the equations by a number to get them to match. So if I take a look here, the thing that I will notice is that the second equation, the coefficient on x, is already negative. So what I can do is just take this first equation, get the variables in x to match, and then eliminate the variable. So if I take a look here, I want 6 to match 12, okay? So what I can do is I can multiply this entire equation by a number. And I'm going to multiply it by 2. And if you're confused on where that 2 came from, take a look at what happens whenever I multiply every term by it. Equation 1 becomes 12x minus 10y equals 16. And negative 12x plus 2y equals 0. Sorry, my big mug is in the way. So what's nice about this is that these two values, 12x and negative 12x, will add to 0 now. So you can add equations just like you add numbers. But if you start out with adding these first two, nothing will cancel out. So you'll just create another equation and it's not going to get you anywhere. But what's nice about this equation in comparison is whenever I add these two equations, 12x and negative 12x will add to 0. Negative 10y plus 2y will add to negative 8y. And then 16 plus 0 will add to 16. And now what I can do is solve for y. I've got negative 8y equals 16. So I can divide both sides by negative 8. And I'm left with y equals negative 2. And in order to solve for x, all I have to do is take y equals negative 2 and plug it into one of these two original equations, or any of the other equations I created. It doesn't matter. As long as y is plugged into one of these equations and I solve for x and I do it correctly, I should get the correct answer. So I'm going to do it for the first equation here, 6x minus 5y equals 8. So 6x minus 5 times negative 2 equals 8. I get 6x plus 10 equals 8. And so if I subtract 10 from both sides of this equation, I get 6x equals negative 2. And so if I divide both sides by 6, I get x equals negative 2 over 6, which reduces to negative 1/3. Okay? So this point of intersection, the point of intersection, is negative 1/3, negative 2. And that's all we have to do for that equation. So I'm going to go on to the next one. So if I take a look here, this one is a little tougher. All right, there's still none that seemingly match. So if I take a look here, the coefficients that it's easy, I mean, for me at least, it's easier to multiply a row by 5 than to multiply it by 6. So if I wanted to match these two, I'd have to multiply the top equation by negative 6. If I want to match these two, I only have to multiply equation 2 by negative 5. So that's what we're going to do. We're going to multiply equation 2 by negative 5. And if you're still a little confused on that, what you should notice right about now is that when I multiply this negative 5 out, right, I'm going to get positive 60x and negative 10y equals 0. And then for the first equation, I've got negative 2x plus 10y equals 2. So what's nice about this is now that I can see this equation, I can add the two equations and they should add to 0. And that's not even the right equation. I have done something horribly wrong as normal. So that is the wrong equation. That first equation should be correct. That second equation is 5x minus 25y equals 3. Yeah, so that's even wrong. So I'm sorry, I apologize. I don't know what's wrong with me, but sometimes I just write the equation completely wrong. Anyway, I digress. What I can do is I can multiply this top equation by 5. And then I can multiply this bottom equation by 2. So if I multiply this top equation by 5, I get negative 10x plus 50y equals 10. And then the bottom equation, if I multiply it by 2, I get 10x minus 50y equals 6. So if you take a look here, negative 10x and positive 10x will cancel. 50y and negative 50y will cancel. And then 10 plus 6 is 16. So I get 0 equals 16. So anytime you get an answer like this, and we're going to double check just to make sure I didn't write anything wrong again, but anytime you get an answer like this for a system of equations, you want to understand that I'm getting a false statement from the original assumption, okay? So this false statement, 0 does not equal 16, so even though it's claiming 0 equals 16, what it's meaning is that these two lines do not intersect. And the only way that two lines in Euclidean geometry cannot intersect is if they are parallel. So let's graph these two in GeoGebra. So give me just a second. There we go. I didn't break it. I didn't break it, I swear. It's working. Go away. Okay, that needs to go away, that needs to go away. And I'm left with negative 2x plus 10y equals 2. So I'm going to graph that guy. And then the other one should be parallel to it. And what you'll notice here is that these two lines are parallel, okay? So because they're parallel, that means they're never going to intersect. So I'm going to get false statements when I try and solve them algebraically. So that's why we're getting 0 equals 16 there. So I hope that made sense. And let's take a look at example 3. I'm going to double and triple check that I wrote down the right problem. Okay, that is the right problem. So we're going to go ahead and work this out. So we want to multiply one or both by a number. And what you should be noticing is that I'm multiplying one by a negative sometimes so that the variables will cancel. So take a look here. Negative 10x and positive 10x cancel. So I like to make sure that the equations are opposite in sign, the coefficients are opposite in sign before I start to cancel anything. You can subtract equations, but it gets a little complicated whenever there's a negative involved, because when you subtract a negative, you have to add it. So, because the opposite of a negative is a positive. And so you have to be really careful with subtracting two equations. So what I tend to tell students is match the coefficients, but get them opposite in sign. So what I'm going to do here is 3 and 2. It's easy to match these two equations. So I'm going to multiply the top equation by 2. So that'll get me positive 6y here. And I'm going to multiply the bottom equation by negative 3. And that'll get me negative 6y down here. But remember, whenever we multiply an equation by a number, we have to multiply every single term by that number in order to make the equation equal. So that top equation becomes 4x plus 6y equals 40. And that bottom equation will become negative 21x minus 6y equals negative 159. And so what we're going to do is add. So 6y plus a negative 6y, that'll add to 0. 4x minus 21, that's going to be negative 17x. And then negative 159 plus 40 is going to be negative 119. And so I'm going to take both sides, divide by negative 17. So I get x equals negative 119 over negative 17. And negative divided by a negative is a positive, and that probably divides evenly. So let's take a look at our graphing calculator. And just to show you that a negative divided by a negative is a positive, that is positive 7. So x equals 7. But we're not finished because we have to plug that 7 back in. So I'm going to pick the top equation to plug the 7 back in. So I'm left with 2 times 7 plus 3y equals 20. So 14 plus 3y equals 20. 3y equals 6. And y equals 2. Okay, so we're left with 7 comma 2 is the point of intersection. And just to not lose sight of what we're doing, if you're confused on what this algebra is trying to show you, why that point is coming out to be that, is what we're trying to do is we're trying to, let me show you. We're trying to graph these two. Visually, this is what we're doing. We're graphing these two and finding their intersection. So GeoGebra is a great site. Lets you see the point of intersection.